Hello, my name is Patrick Harvey, and what we have here is we have a derivation of Flynn's density challenge. When I first looked at Flynn's density challenge, I found that it wasn't challenging enough. So what we did is we tweaked it a little bit in order to make it a little more challenging for your class, and so that the class themselves will have to come up with their own procedure and basically put a little more thought into it. And then the idea of the density challenge is for it to be challenging, and what we want them to do is challenge the other students. So what I did is I printed out the sheet from Flynn, and right down on the bottom where it says procedure, I just completely took that out and instructed the students that they have to come up with their own procedure. So let me give this to you in a nutshell. What they are going to do is they are going to be given a film canister. And with the film canister, they have to fill the film canister up with as much sand as possible, but the film canister must float. All right? So how this is challenging is the groups, and we'll have 2 people per group in a class, the groups with the highest amount of sand will get the highest grade. And I actually told the number 1 group will get 105. Everybody else will be based off of that benchmark. So what we're doing is we give the lab to them a day ahead of time and tell them to come in, and you ask them whether they have a procedure or not. But the day when you give it to them a day ahead of time, you give them one bit of information. You give them the formula for figuring out the volume of a cylinder. And this is the formula for figuring out the volume of the cylinder. Hopefully, they're going to work this into their procedure. Again, you don't tell them how to do it. You just give that to them. Okay? Now, they'll come in the next day, and you just check whether they had the procedure done. Then you will break the students up into groups of 2. When you break them up into groups of 2, you give them a film canister, as much sand as they want, and a ruler. And tell them, go ahead and fill your canister up with sand. You do not give them a tray of water because you are the only one that has a tray of water. They get an attempt to make their canister float, but they only get 1 attempt. So what that means is they have to go over with their partner and work out some way of measuring this canister, and their goal should be, how do they get this canister so that it has a density as close to water as possible, but slightly below it. If they get it as close to water, slightly below it, it will float, but it will also have the maximum amount of sand in it. All right, so what we're going to do is you give them, right, this would be only 1 period, and you tell them to come up when they're ready. When they come up when they're ready, they write their name down, and you take the cylinder, they write their name down and the mass. You take the cylinder and you pop it in. This one obviously doesn't have a lot in there and floats very, very easily, and you would probably tell them, okay, that's probably not going to win, all right? But since they're the first person, they get to be number 1 on the list, all right? You do not tell them or tell the class how much mass is in there, but you do go over, because they're going to tell you what the mass is, but then again, you probably want to check it yourself and check the mass again, because later on, when you're doing this density challenge, some of the students may be very close to each other, so I use my measurement as opposed to their measurement. And at that point, you pour the sand in there and they're done, and you tell them their place. Their place obviously is going to move up and down. Now, some of the teachers may say, well, why don't they just give the information to the other students? If they give the information to the other students, they will be moving their place down farther and farther and farther. So once they're informed of that, they will keep their mass a secret, and you don't tell anybody but their mass. You only tell what place they're in. See, one of the rules that we have in here, though, is if a student just loads it up and puts it in there and it just sinks, they're out of the running and they get into that group that is down on the bottom. Now, the group that's down on the bottom, we're obviously not going to write in there and say, okay, you failed the lab, but they have an extra part of the lab that they have to do. They have to go and on the bottom of the lab explain why their canister sunk. And then they'll get some of their points back, and you can, from that point, decide how many points they're going to get back from there. Okay, as you do this, you'll see after the first try, people will start getting very, very competitive, and some of them will go back and redo their calculations, and some of them won't want to put theirs in there first, etc. But it becomes a bit of fun after a while, and you get to sit there and watch it, and some of them, again, the ones who are winning will float just at the top. All right? Now, the students who are very meticulous about measurement are the ones who are going to do very well. When they do the volume of the cylinder, some of them are going to notice that the volume of the cap makes it different than the rest of the cylinder, and we'll factor that in. Or some of them will say that's going to change the density a little bit, so I will up my mass or decrease my mass to take into account that right there. And those are usually the people who are probably going to win the challenge. All right, so go ahead and do that, and then at the end of class, you can tell which student came in first, second, third, etc., and then you can decide what your grading scale is based on that. So it's a lot of fun. Give it a try. It only takes about one period, and it gets the students involved in the experiment. Thank you.